Okay, this screencast is on exponential functions and logarithms. Two new functions for you at this stage of your mathematicals of your young mathematical career. So we're going to take some time just to explore them. Now, firstly, the exponential function. The exponential function. Now, the exponential function, as its name suggests, uses exponents. Now, exponents are a fancy word for index or power. It's got so many different ways of referring to this guy here. Right? That is a power of 2. It's also called an index. It's an exponent. So an exponential function deals with exponents, and specifically for us, functions of the type. I just need to write that out, perhaps. Exponential functions are functions of the type, new color, y equals a to the power of x, where a is a constant. So this here, this unknown x is in the power, or the exponent, and that's what's new about this, because you've done y equals x squared. You know all about y equals x squared, the parabola, and you've explored that and you've studied that, but we haven't looked at functions of this nature before. These are exponential functions where the x is in that exponent. So if we have a little look now at graphing y equals a to the power of x, and what we should do here is perhaps we give a value so that we can get started. So let's look at, rather than just write, let's look at the graph of y equals, let's say, just 2 to the power of x. Okay, in order to have a look at the graph of y equals 2 to the power of x, we are just going to go right back to basics and just start collecting some points. So let's have a look. So when x is equal to, we could just get a little table of values out here, and we can have a little positive table of values. We go from 0, 1, 2, 3, and we could have a little negative table of values that go from x to -1, -2, -3, etc. Okay, can you fill in the table? Well, then x is 0, 2 to the power of 0 is 1. I'd love you to pause the video here and fill out these values. As I said in this previous screencast, taking an active approach to these lessons is going to benefit your learning. Okay, perhaps you've filled out the tables now, but I'm going to just whip through them. 2 to the power of 1 is 2, 2 squared is 4. I'm just substituting this value in here for x. 2 cubed is 8. Okay, so I can plot these points 0, 1, 1, 2. All right, so that's fine. 2, 4. So now if I'm just trying to get a little bit of scale with this, every time I go across 1, 4, 8, I'm doubling, and that's a feature here of exponential functions. And you might have heard of the term exponential growth. It's when things increase. It's like a population. The bigger the population, the bigger the growth. The bigger the growth, the bigger the population, etc. So that's an exponential growth curve there. Let's go to the left now. What happens at x equals -1? Well, 2 to the -1 equals, we know all about that. It's 1 over 2 to the positive 1. 2 to the -2 is 1 over 2 squared. 2 to the -3, put a -3 in here, it's 1 over 2 cubed, 1 over 8. So when x is -1, it's a half. When x is -2, it's a quarter. So we're getting, this is me jumping halfway to the wall, isn't it? Literally. We're getting close and close and close, but we're not going to reach the x-axis. And what's that called? That's called an asymptote. So the x-axis is an asymptote, which is at y equal to 0. It's a horizontal asymptote. We don't have a vertical asymptote. While we're talking about it, we can refer to the range, also the domain of this function. Just to bring in a bit of previous learning, domain would be, well, are there any values of x that we don't have a function value for? Well, no, we can put in any value of x, can't we? From left to right, we're scanning. So this is going to be, remember how to represent this? -infinity to infinity. And our range, well, they're our y values, our output values. So do a horizontal scan now. We've got no negative values, do we, for y? and we pick it up at the positive values greater than 0. So not including 0, but all the way to infinity. That would be our range. Okay, so there's our sketch of y equals 2 to the power of x, and that's an exponential function. Now we can look at some basic transformations on that. Now if that's 2 to the power of x, then 2 to the power of minus x will reflect in the y-axis. Remember, if we minus f of minus x flips in y, whereas minus f of x flips in x. When I say flip, obviously I mean reflect. Okay, so this sketch here is that there is y equals 2 to the minus x. But if we want minus 2 to the power of x, then the red will flip in the x-axis and will look a bit like this. So this will be y equals minus 2 to the power of positive x. And you get the idea. If it's minus 2 to the negative x, then this is going to flip across. It'll do something like this, and we can go on. Okay, I want to refer quickly to the natural exponential function. The natural exponential function. Now the natural exponential function, I'm going to hold off on explaining the significance of this value, but the natural exponential function is y equals e to the power of x. Now this value of e is a constant like pi. It's an irrational number. It goes on forever and ever, 2.71, etc. I'm gonna just save the fun till later to work out or to develop what is the significance of this 2.71. But you might see natural exponential function. You might also see natural logarithmic function referred to, and that's what it refers to. It refers to this e. Read e as pi. It's a Greek letter, and it has this value. It's a constant. Okay, I'm going to move now into. Actually, I might stop it there, and I'll make a separate YouTube for logarithms. So that's all I'm going to say on exponential functions. Other than perhaps just it might be an idea to recap on page 113. So recap the transformations. So graphical transformations of the exponential function. Recap transformations on page 113. Just goes through the basic transformations which we looked at in our functions unit of work. So I'll leave it there. I'll put together another YouTube for logarithms, but we can now, on the basis of this lesson, we can work on exercise 4F. Actually, exercise 4F only. Exercise 4F. Okay, see you soon.